Somewhere beneath the border between France and Switzerland, 100 meters underground, there is a machine colder than outer space and emptier than the vacuum between the planets, propelling particles of matter at 99.99% of the speed of light. Now imagine it's yours, not to visit, but to operate, to keep alive. Because the moment you own the Large Hadron Collider, you inherit a machine that is trying to destroy itself every second of every day, and the only thing standing between it and catastrophe is you. People imagine that owning it would feel like owning the fastest car in the world. It does not. It feels like owning the coldest object on the planet and being personally responsible for keeping it that way. The collider is a ring 26.7 kilometers around, buried about 100 meters beneath the border of France and Switzerland, and along almost its entire length runs a chain of 1,232 main superconducting dipole magnets, each one roughly 15 meters long and weighing around 35 tons. Those magnets only work if they are superconducting, and they only become superconducting if you chill them down to 1.9 Kelvin. That is minus 271.3 degrees Celsius. It is colder than deep space. The cosmic microwave background, the leftover heat of the Big Bang that fills the entire universe, sits at about 2.7 Kelvin. Your machine runs almost a full degree colder than the average temperature of the cosmos itself. You do not own a particle accelerator. You own the largest refrigerator ever built, and the particles are almost an afterthought. To reach that temperature, you do not simply use liquid helium. You use superfluid helium. When you cool helium below about 2.17 Kelvin, it stops behaving like a normal liquid and enters a quantum state with no measurable viscosity, a substance that conducts heat better than any ordinary metal and creeps up the walls of its container against gravity. Your machine holds roughly 120 tons of helium, and a large fraction of it is chilled into this superfluid state and pushed into the cold mass of the magnets. Keeping it there is not free. The cryogenic plant that maintains this cold, 8 enormous refrigeration stations spaced around the ring, draws on the order of 27 megawatts of electrical power on its own, not to run experiments, not to collide anything, just to stay cold. That is roughly the continuous power demand of a small town, spent entirely on refusing to let the temperature of an ordinary room touch your machine. Now think about what you are actually holding at that temperature. Cooling 36,000 tons of magnet and structure down to 1.9 Kelvin is not something you do in an afternoon. It takes weeks. The cool down of the full ring runs for something like 4 to 6 weeks, staged carefully, so the metal does not tear itself apart as it contracts, because everything shrinks. A 15-meter magnet loses centimeters of length as it falls to cryogenic temperature. Kilometers of interconnected pipework pull inward. The entire machine, all 27 kilometers of it, physically contracts as you cool it, and every joint and bellows and connection has to absorb that shrinkage without failing. When you own this thing, you do not flip a switch and turn it on. You spend a month and a half convincing a continent-sized machine to slowly freeze into the coldest thing for light years in any direction, and only then are you ready to begin. But temperature is only the first thing trying to kill your machine. The second is air. Ordinary air, the stuff you are breathing as you listen to this, is a catastrophe for a proton beam. A proton traveling around your ring will smash into any stray molecule in its path and be lost. So the beams travel through a pipe that must be emptier than the space between the planets. The vacuum inside the beam pipe of the LHC is pumped down to around 10 to the minus 10, even 10 to the minus 11 millibar. To put that in human terms, the pressure inside your beam pipe is roughly 10 times lower than the atmospheric pressure measured on the surface of the moon. You own, in the most literal engineering sense, one of the emptiest places that has ever existed inside the solar system, and you built it on purpose, and you maintain it with hundreds of vacuum pumps because if that emptiness fails anywhere along the ring, your beam dies. And there is a second vacuum, layered around the first, that most people never hear about. The magnets are cold, and the world is warm, and heat does not only travel by touch, it radiates. So the entire cold mass is wrapped inside an insulating vacuum, a thermal blanket of nothing, tens of thousands of cubic meters of vacuum, whose only job is to stop the warmth of the surrounding rock from reaching the superfluid helium. When you own this machine, you are maintaining two different kinds of emptiness at once: the beam vacuum where the physics happens, and the insulation vacuum that keeps the beam vacuum cold. Two nested voids, both of them yours to keep perfect. Then there is the electricity, and this is where owning the collider stops feeling abstract and starts feeling like a utility bill that could bankrupt a nation. When the machine is running at full tilt, the CERN site peaks at around 200 megawatts of power draw, with the collider machinery itself accounting for roughly 120 of those megawatts. Across a full operating year, the laboratory consumes about 1.3 terawatt-hours of electricity. That is enough to power around 300,000 homes for a year. It is roughly a third of the electricity used by the entire nearby city of Geneva. You are not paying a power bill. You are paying a power bill the size of a small city's, and you are doing it to make invisible particles go around in a circle, which is why, if you owned this machine, you would learn to fear winter. Electricity is more expensive in the cold months, and the strain on the European grid is higher, so the collider does not run year-round. Every year it powers down for a period, dropping the site's demand from around 200 megawatts to about 80, and this is not laziness. It is arithmetic. It is cheaper and kinder to the grid to stop. You own the most sophisticated machine humanity has ever constructed, and part of owning it is accepting that you cannot always afford to switch it on. The power itself comes across the border from France, drawn largely from that country's carbon-free nuclear generation, with Switzerland standing by as a backup supply, because a machine this hungry cannot survive on a single national grid alone, and that is only the running cost. The machine and its infrastructure charged to CERN's budget came to somewhere above 4.3 billion Swiss francs. And once you add the enormous detectors, the computing, and the decades of work behind them, the full price of the project is usually put in the range of $7 to $9 billion. Nearly 2 decades of planning and building went into it before the first beam ever circulated. When you own the Large Hadron Collider, you own an object that took a generation of physicists and engineers and the treasuries of dozens of nations to bring into existence, and which still needs feeding, cooling, and pumping every single day to remain what it is. And here is something the tours and the photographs never quite tell you. When you own the Large Hadron Collider, you do not own one machine. You own 5, arranged like a set of nested launch stages, because a proton cannot simply be dropped into the main ring and told to go. It has to be brought up to speed in steps. The protons themselves begin their life as ordinary hydrogen gas from a bottle so small it lasts for years, because the actual mass of matter you accelerate across an entire year would barely register on a kitchen scale. From that bottle, the protons are stripped of their electrons and fed into a linear accelerator called LINAC-4, which pushes them to 160 million electron volts. From there, they pass to the proton synchrotron booster, then to the proton synchrotron, then to the super proton synchrotron, a 7-kilometer ring that is itself one of the largest accelerators on Earth, and which here serves only as the final on-ramp. Each machine hands the beam to the next, faster than before, until the super proton synchrotron injects protons already traveling at 450 billion electron volts into the main ring. Only then does your collider take over and spend around 20 minutes ramping them the rest of the way. So when you own the LHC, you own a relay race of accelerators, decades of engineering stacked one inside the next, and the famous ring is merely the last runner. Now, finally, we arrive at the beam, the thing everyone actually pictures. Inside that perfect emptiness, held in place by those impossibly cold magnets, you accelerate protons until they are moving at 99.9991% of the speed of light. At that speed, a proton laps your entire 27-kilometer ring 11,145 times every second. To bend something moving that fast around a circle, ordinary magnets are useless. This is why the whole machine has to be superconducting. At full energy, those 1,232 dipoles generate a magnetic field of 8.33 Tesla, around 100,000 times the strength of the Earth's own magnetic field. And it takes a current of nearly 12,000 amps flowing through the magnet coils to do it. That current only flows without melting the wire, because the wire is colder than space. Everything connects. The cold exists to allow the magnetism. The magnetism exists to steer the beam. The emptiness exists so the beam survives. Pull out any one of these and the entire machine is just an expensive, freezing hollow ring. The protons do not travel as a smooth stream either. They ride in tight packets called bunches, up to around 2,800 of them in each beam, and each bunch is a swarm of more than 100 billion protons squeezed together. Those bunches are spaced 25 nanoseconds apart, which means that at the 4 collision points, bunches from the 2 beams pass through one another 40 million times every second. To keep them tightly packed and to feed them a little more energy on every single lap, the machine uses radio frequency cavities, superconducting resonators oscillating at 400 million cycles per second that give each bunch a precisely timed electrical kick as it passes, like pushing a child on a swing at exactly the right instant, 11,245 times a second, for hours on end. When you own this machine, you are not steering one object. You are shepherding thousands of dense clouds of protons, holding each one in formation against its own tendency to fly apart, keeping the whole choreography synchronized to the nanosecond around a 27-kilometer loop. A drift of a few billionths of a second anywhere in that timing, and the bunches miss each other entirely. Here is the part that should frighten any owner. Each of the 2 counter-rotating beams, at full intensity, carries a stored energy of several hundred megajoules, on the order of the kinetic energy of a high-speed train at full speed, compressed into a thread of protons thinner than a human hair. If you lose control of that beam, it does not gently dissipate. Reporting from the machine's early years described an uncontrolled beam as capable of melting around 500 kilograms of copper in an instant. Your beam can drill a hole clean through the machine that contains it. This is why one of the most important systems you own is not for making collisions at all. It is the beam dump, a mechanism that can, in a fraction of a millisecond, yank both beams out of the ring and fire them into a specially built block of graphite designed to absorb that train's worth of energy without vaporizing. Owning the collider means owning, first and foremost, a reliable way to throw the beam away before it destroys everything else you own. And what is all of this cold, and emptiness, and power, and violence actually for? Collisions. When you finally bring the 2 beams together at the 4 points around the ring where the great detectors sit, the protons cross through each other, and up to around 1 billion times every second, 2 of them actually strike. From that billion per second rain of collisions, the experiments record their harvest, and across a year, the LHC's detectors generate on the order of 90 petabytes of data. This is the strangest part of ownership. You have built the coldest, emptiest, most energetic machine in human history, and its product is not a substance. It is information. You spend a small city's electricity, you maintain 2 vacuums and a temperature colder than the sky, you tame a beam that could burn through steel, and what you get to keep at the end of it all is data about what happened in the instant 2 protons touched. Almost every collision tells you nothing new. You are paying, at staggering cost, for the rare, near-impossible event hidden inside 1 billion ordinary ones. And you cannot even keep most of the data. This is perhaps the most counterintuitive thing about owning the machine. 1 billion collisions a second is far more information than any storage system on Earth could ever write down. Recording all of it would mean saving something like a petabyte every second. So the detectors are wired with a system called the trigger, a bank of custom electronics and computing that looks at each collision in real time and makes a brutal decision in a fraction of a microsecond. Interesting, or discard. It throws almost everything away. Out of those roughly 40 million bunch crossings per second, only a few hundred to a few thousand events survive to be written to disk. You own a machine whose most important skill, after making collisions, is forgetting them. Deleting the overwhelming majority of the most expensive events humanity knows how to produce. Because the one collision in 1 trillion that might contain something new is worth more than all the ordinary ones combined. To own the collider is to fund the largest deliberate act of forgetting ever engineered, in the hope of catching the few things worth remembering. I want to tell you about the day an owner of this machine learned exactly how unforgiving it is. On the 10th of September 2008, the LHC circulated its first beams to enormous fanfare. 9 days later, on the 19th of September, during a test of the magnets, a single faulty electrical connection, one imperfect soldered joint between two magnets in a machine with tens of thousands of them, failed. The current could not pass cleanly. An electrical arc punched through the helium enclosure, and the cold mass suddenly, catastrophically warmed. Around 6 tons of liquid helium erupted into the tunnel. The pressure wave tore magnets from their concrete anchors. 53 magnets were damaged. The machine that had switched on 9 days earlier to global celebration was now broken, and it stayed broken, under repair, for more than a year before beams circulated again. One joint. In a machine of that scale, a single connection no larger than your thumb was enough to take the whole thing down for 14 months. That is what ownership of something this extreme actually means. There is no part too small to end you, so go back to the machine we started with. Colder than outer space, emptier than the void between the planets, its matter moving a breath below the speed of light. Every one of those extremes is not a feature you get to enjoy. It is a fight you have to win, again, every second. The cold is a fight against the ordinary warmth of the rock around it. The emptiness is a fight against a single stray molecule of air. The speed is a fight against a beam that would burn straight through the machine the instant you lost your grip on it. That is what it means when I say the collider is trying to destroy itself every second of every day. It is not a metaphor. It is the job. You would not own a discovery machine. You would own that fight. And the physics, the part that gets the headlines, would turn out to be the easy part. The hard part, the real thing you would own, is the daily, relentless refusal to let the universe pull your impossible machine back down to something ordinary. It is the coldest place for light years, kept that way by hand, so that for a few months a year, 1 billion times a second, 2 specks of matter can touch. That is what it is really like to own it.